For this project, you will need 10 jumper wires, 1 buzzer, 4 buttons, and 4 resistors. One 220 ohms resistor, 1 mega resistor, and 2 10K resistors. Take the breadboard and place it sideways. Attach a buzzer on the breadboard. Attach 4 buttons on the breadboard. Connect the right ends of all the buttons together using jumper wires. Connect the positive side of the breadboard to the left end of the first button using a jumper wire. Connect the 220 ohms resistor between the positive side of the breadboard and the left end of the second button. You can use jumper wires if necessary. Connect the 10K ohms resistor between the positive side of the breadboard and the left end of the third button. You can use a jumper wire if necessary. Connect a 1M resistor between the positive side of the breadboard and the left side of the last button. You can use a jumper wire if necessary. Connect the 10K resistor between the negative side of the breadboard and the right end of the last button. You can use a jumper wire if necessary. Connect the positive end, which is the longer end of the buzzer, to Arduino pin 8 using a jumper wire. Connect the negative end, or the shorter end, of the buzzer to the negative side of the breadboard using a jumper wire. Connect the negative side of the breadboard to the ground pin of the Arduino using a jumper wire. Connect the positive side of the breadboard to the 5-volt pin on the Arduino using a jumper wire. Connect the right end of the last button to the analog A0 pin on the Arduino using a jumper wire. Open the Arduino software and create a new file. Before we continue, you should know that each frequency produces a unique musical note. Note C is 262 Hz, Note D is 294 Hz, Note E is 330 Hz, and Note F is 349 Hz. Each button will produce a different note from the buzzer. Each button has a different key value because of the different resistors they are connected to. Each button will send different key values to the buzzer, and based on the key values the buzzer receives, it will play a certain sound. Assign a variable to the buzzer according to the pin number and create an array called notes with all the 4 different frequencies. Set up the serial monitor so that we can see the key values. Read the resistance values from the pin A0 when a button is pressed and print the key value on the serial monitor. The resistance is highest for the first button and reduces for the other buttons. Write the code to play certain notes depending on the key value. The function tone in the code is used to produce the noise according to the frequency of the musical note. If the key value is 1023, then the buzzer will play note C. If the key value is between 990 to 1010, then the buzzer will play note D. If the key value is between 505 to 515, then the buzzer will play note E. If the key value is between 5 to 10, then the buzzer will play note F. If no button is pressed, the buzzer will make no noise. Connect Arduino to your device using the USB to B cable. Go to Tools, select Ports, and select Arduino. Compile your code by selecting the check button, and if you have any errors, fix them. If your program has no errors, the console window will say that there are no errors. Upload the code by pressing the upload button, and you should hear the notes from the buzzer depending on which button you pressed. Open the serial monitor under Tools and check the key values. Make sure the baud rate is set to 9600 on the bottom right. Press the buttons to hear different notes and see the key values on the serial monitor.